All right, welcome. Today we are diving deep into the very fabric of our number universe. And you'll find it's a universe divided, really. It's split between two rival kingdoms. In one corner, you've got the orderly, the predictable, the numbers that follow the rules. And in the other, you've got the wild, the chaotic, the rebels. Yep, we're talking about the epic story of rational versus irrational numbers.
But before we get into all that, let me start with a little puzzle, one that really gets to the heart of what we're talking about. How is it possible for a number to have a decimal that just goes on and on forever, but at the same time, it's not random at all? I mean, it sounds like a total contradiction, right? But the answer you'll see is hiding in plain sight. And this is our map for the journey. It might look a little complicated, but don't worry. This is the entire system of real numbers, basically any number you could possibly point to on a number line. For today, we're just going to focus on the two main territories you see branching off here, the rationals and, you guessed it, the irrationals.
Okay, so our first stop is the kingdom of the rationals. You can think of this place as a realm of perfect order, total precision, and predictability. Every single number that lives here plays by a very clear set of rules. So zooming in on our map, you can see the rationals, which mathematicians love to label with the letter Q. This kingdom is huge. It covers all the whole numbers, all the integers, and of course, as the caption says, the entire land of fractions. So what's the one single law that governs this entire kingdom? It's actually pretty simple. Every number here, every single citizen, must be able to be written as a fraction, a over b. As long as a and b are integers, and this is the important part, b isn't 0, you are officially in the rational club. Now, when you look at how these numbers behave as decimals, you'll find they have two very distinct personalities. They either terminate, which means the decimal just stops, cleanly, like 1/8 is just 0.125. Boom, done. Or they are recurring, where the decimal goes on forever, but in a perfectly predictable, repeating pattern. And that right there, that's the answer to our little puzzle from the beginning. Their decimals can be infinite, but because of that pattern, they are never, ever random.
And here's something that'll really bake your noodle. This kingdom of rationals is incredibly dense. If you pick any two rational numbers, no matter how close together they seem, you can always find another one right between them. In fact, you can find an infinite number of them. The place is absolutely packed.
It's a very stable, self-contained little world. If you add, subtract, multiply, or divide any two rational numbers, the result is always going to be another rational number. They really do keep it all in the family. Okay, now let's see how this tidy little world stacks up against our next stop.
We are now leaving the neat, orderly cities of the rationals and heading out into the wild frontier. This is the realm of the irrationals. These are the rebels of the number world, the ones that just refuse to play by those nice, neat fractional rules.
And this is the question that unlocks the door to this whole new territory. We saw that rational numbers either stop or repeat in a pattern. But what if a number does neither? What if its decimal form is just an endless, chaotic-looking string of digits with no pattern in sight? Well, welcome to the irrational numbers. The most classic example is the square root of 2. If you actually try to write it out as a decimal, it just keeps going and going and going, with absolutely no repeating pattern to be found. It flat out refuses to be pinned down as a simple fraction.
And that right there gives us our official definition. An irrational number is simply any real number whose decimal form never ever ends, and it never ever settles into a repeating loop. It is the complete and total opposite of a rational number.
And this wild frontier has some pretty famous inhabitants. You've got all the square roots of numbers that aren't perfect squares, like root 2, root 3, root 5. And then, of course, there's the absolute superstar of the irrational world, pi. You know, the ratio of a circle's circumference to its diameter, whose digits just march on into infinity with no pattern whatsoever. So, okay, these numbers are wild for sure, but they're not totally unmanageable. Mathematicians have actually developed some really cool techniques to work with them. Think of it like a kind of diplomacy for handling their unpredictable nature. We call it rationalization. So here's a problem that pops up all the time. For a lot of math, it's just considered messy or sometimes just plain difficult to have a wild, irrational number lurking in the denominator of a fraction. So the question is, how do we clean that up?
The answer is rationalization. And the core idea is actually brilliantly simple. All we do is multiply the fraction by a very cleverly chosen version of the number 1.
Now, doing that doesn't change the fraction's value at all, but it magically transforms the denominator from an irrational number into a nice, clean, rational one. Let's just see it in action. It's super easy. To rationalize 1 over the square root of 2, you just multiply the top and the bottom by the square root of 2. On the bottom, square root of 2 times square root of 2 just gives us a clean, rational 2. And on the top, we have 1 times the square root of 2. The value is exactly the same, but that new form, root 2 over 2, is just so much easier to work with.
All right, so we've visited the orderly kingdom of the rationals, and we've explored the wild frontier of the irrationals. So how on earth do these two opposites coexist? Well, they actually come together to form the complete unified universe of the real number line.
So here it is, the final showdown, a side-by-side comparison. On one side, you've got the rational numbers, the world of neat fractions and predictable decimals. And on the other, the irrational numbers, the rebels that can't be tamed into a fraction, whose decimals are just an endless, patternless adventure. And this brings us right back to our map, full circle. Every single real number, every single point you can imagine on the number line, belongs to one of these two great kingdoms. Together, they leave no gaps, no empty spaces. They fill the lineup completely with every possible value.
So that just leaves us with one last kind of mind-bending question. We know the number line is completely full, but which group is bigger, the orderly rationals or the wild irrationals? Well, the truly astonishing answer is that there are infinitely more irrational numbers than rational ones. It turns out that the wild frontier is unimaginably larger than the